Data structures from computer science might seem a bit complicated. If you want a simple view, watch this video. We mentioned linked lists. So linked lists, we have nodes, which we link together. The nodes have two parts. The first part, we can store a value. The second part holds a reference to the next node. So you can see here, these nodes are all linked together, like a linked list. The first node we can call the head, and at the end we point to none. So we know that's the end of the linked list. Now, where do we see linked lists implemented? Well, they're implemented in queues and stacks and graphs and other uses. Here's a list of reasons when you might use a linked list. Hash tables. We want to be able to access elements by the index easily and quickly. But how do you know the correct index? What about if you could relate the index to the actual value? So one way of doing this would be to use a function on the value to create the index and then use that function to identify the index. And this is called a hash function. What does this mean? Well, here's an example. We've got a value, we've got this integer. Now we've got a list of size 10 elements. So if we use modular, we can change its integer to the value 2. And then we can put that value inside the list at the place at index 2. What about strings? Well, here we use a hash function using the ASCII code. So we have a name, Tim, we get the values, add them up. List is size 10, we use modular, and after modular the remainder is 8. So we can put the word, the name Tim, in the list using index 8. So we can carry on doing this with different names, and we can fill out our list at the index using the modular and the ASCII codes. And that's what's used in this hash function in this example. Now, what happens when we've got a collision? So we want to put Leo in, and Leo's also at index 8. One way is to just move to the next slot. If that's full, then we move to the next slot and we keep going. If there's no more available slots at the end, we begin at the start. So in this case, Leo will go into the first location in the list at index 0. This is called linear probing, and it's a type of open addressing. You could make the hash table bigger. So if you have very few elements and a huge hash table, that's not very efficient. If you have many elements and a smaller hash table, you're going to get a lot of collisions. So you need to understand or how many elements you're likely to need to understand what size hash table you need. Another method to deal with collisions is called chaining, which is a form of close addressing. Here we use a linked list. So at a place index 8, we have a link to the node with the value Tim, and that node with the value Tim then links to the second node with the value Leo. So we have a cost. In linear probing, we've still got to find the element. If it's not at the index that we expect, and we've got to find it afterwards. So this is like a linear search. Also, if we use chaining, we have to traverse the linked list. So there's different cost values. Which one's better depends on the load factor, which is the size of the hash table and the amount of values. Now there are other approaches for collision resolution, such as double hashing, where you use the first hash function, and if there's a collision, use the second hash function. Also, we can use hash table not just for values. Instead of storing the value, we can store keys, and those keys can have values such as in a dictionary, or even we could use objects. Now, what do we use? Well, as I said, in Python, a lot of these data structures are already implemented. We don't need to understand or write all of the code because Python's already given it to us. So a dictionary is already a good way to store values using a key. As long as that key is unique, that's fine. make your data so you can have a key that's unique. We already do that in databases. So for example, say we've got many students at a university. Some students could have the same name. So we make sure every student is unique by registering every student so they have a student ID. And now we can identify any student because each student ID is unique to that student. And we know as soon as each student is registered that they have an ID number. This is called a primary key in databases, and it makes everything a lot more simple and easy to use. So when you're thinking of data structures, you have to think about the costs of what you're going to do. Do you need to sort the items? Do you need to access them quickly, for example? So in a database, if you want to access something quickly, you use a number and you make it unique. That's the best primary key. So dictionaries, what can we use as a key? Well, it has to be unique. Hashable means like apply hash function on it. Immutable, meaning that it has to not change. If you're going to apply a key at any time, it has to have the same value. So if we apply a hash function on a key, then that key can't change value, otherwise the hash function will give a different return value, and then we won't be able to access our item. So in a dictionary, we have a key and a value, and the key can't be something like a list or another dictionary because they can change over time. The value can be mutable, it can change. So we can use other data structures as values in a dictionary, other dictionaries, lists, etc. One thing that we need to know is if we try to access a dictionary element, like a value, and we use a key that doesn't exist, we get an error message. So rather than have your code crash, we can use a function called get. So let's quickly look at this. We have a list called words, we create a dictionary called tally, and then we're just going to add up all the amount of words that are in the list. And you can see here we've got the 4 words on, in, at and is, and they all occur once except for in, that occurs twice. So this is a good way of tallying up how many words are in a text file, for example. Okay, if you've enjoyed that video, please give us a like, and if you haven't already, please subscribe. Listen out for the next videos. We're not sure when we'll be able to provide them, so make sure you click on a notification, and then that will let you know when the videos are released.